Hi, today let's solve this problem. So before we start, I want you to pause the video and read the question carefully. Now you've read the question, you understand we are looking for k, and also we understand that the function has a minimum value of 18. Meanwhile, the function itself also contains quadratic function, so it's something to do about combine the two together. You can deduce that the question is something about vertex value of this function. So then we have to think about what vertex involves, what it pertains to. So we have to keep that in mind. So there are different ways to solve the problem. First of all, you can just plug in on Desmos, and if you know your way around it, it should be quite straightforward problem. But now, here, we're going to do it differently. We're going to do it in traditional way. So what we're going to do is we're going to equate the function to 18 because that's what the minimum value was. So if you simplify the equation further, we're going to end up with this. Now, here's the important thing. This one is important. Since it's talking about minimum value and it is quadratic equation, we can deduce that this equation must have its discriminant being equal to 0. Discriminant being equal to 0 because it involves minimum value. So minimum value means it has only one solution. If it has only one solution, its discriminant must be equal to 0. So once we deduce that, once we establish that, everything else becomes quite straightforward. So if we think about it now, discriminant of this function is equal to 14 squared minus k plus 90, right? So it ends up being 196 minus k minus 90, or 106 minus k. This must be equal to 0. From here on we can say k must have value of 106, which would be this answer. So that's how you solve this kind of problem. And in our SAT prep courses, we do problems like this, of course, but more importantly, we exhaust the methods to approach the problem. In that way, so when exam day comes in, you would know the easiest or the fastest way to solve the problem. Just like today, we approach this problem in two different ways. We established that, and this one is traditional way of approaching this problem. Okay, doc. Thanks for tuning in. Bye.